Sunrise, when a tiny bit of Earth comes face to face with the sun as our planet rotates. Birds begin to chirp and alarms begin to go off in our homes. Everything is filled with light and a new day begins. But did you ever wonder why light really is? How does it travel so fast? How does it get to be all around us? And why are we so helpless without it? For a very long time, people believed that light was an element of the universe because all the light they had came from fire of some sort. For example, they saw the sun, which gives us light during the day, as a great fireball, while the light they received at night came from lamps or logs of burning wood. Over the time, scientists did experiments and theorized that light was some form of wave that moved through an invisible substance that is called ether in space. Just as waves move on the surface of the sea, later various experiments highlighted that light is actually made of tiny particles. Yes, light is made of tiny particles. It was experimented and was told by the scientists these particles are called photons. Yeah, and have no weight at all. They have no weight, but have energy that can be measured. But they have energy, but no weight. All right. Today, several scientists believe that light is both. Light is both. It means a wave nature and particle nature at the same time. This is called the wave particle, and this is called wave particle duality. Then there is nuclear fusion reactions deep inside stars are the source of all the photons in our universe. They're the source of photons which are present in our universe. Now the speed of photons traveling in vacuum is 299,792 kilometers per second. As photons are massless. Now, the photons, as I told you, they have no weight, photons, and they are massless. Nothing heavier can travel faster than them. However, light does slow down when it enters a gas, liquid, or solid, where it interacts with the electrons of the material. The speed of light is 225,000 kilometers per second in water and 200,000 kilometers per second in glass. Incredible individuals. At college, Max Planck wanted to choose physics, but his professor told him that it would be futile at all the discoveries had been made. Planck went on to study physics anyway and ended up changing it forever with the quantum theory. So we'll be talking about quantum theory, and it's about Max Planck, whose contribution was so much, along with Albert Einstein. So it's about like his physics professor, I guess. No, his professor said that all the discoveries had been made. What would you even do there? So you should not opt for physics, but he did anyways, and he changed everything in physics and introduced quantum theory to us. In 1900, the German scientist Max Planck suggested that all energy existed in fixed quantities or the fixed units, which are called quanta. The more quanta of energy a substance has, the more energy it possesses, either as electricity, heat, light, or magnetism. For example, each quantum of electrical energy is an electron. The more electrons a wire has, the more current it carries. So it's just simply that all type of energies, no matter what, it can be electricity, heat, light or magnetism. Yeah, so they have some fixed units. For example, for electrical energy, the fixed unit is an electron. Now this electron is nothing but quanta. It's quanta of electrical energy, each quantum of electrical energy. So here, electron, more the electron, it means more the quantas, more the quantums, the more the energy, more the electron, more the energy. All right, so the more electrons a wire has, the more current it carries. For his theory, Planck won the Nobel Prize in Physics in 1918. But what about other forms of energy, such as light? So in 1905, the Swiss scientist Albert Einstein suggested that light too is made of tiny quanta. So the quanta of light, so if I'm talking about quanta of light, those are called nothing but photons. So he told us about this. The more photons in a beam of light, the brighter it is. It means more photons equal to brighter light. He theorized that not just energy, but even radiation itself can be quantized in the same way. Even radiations can also be quantized in the same way. Today, an entire field of physics called quantum theory, this is what we're talking about, quantum theory. So, entire field of physics, which is called quantum theory, studies how quanta of various kinds of energy behave, particularly photons. But not all photons are the same, for their energy depends on their frequency. Now, wavelength and frequency. Each photon oscillates a number of times per second. You know what an oscillation is? Each photon oscillates a number of times per second, even as it is moving forward in a beam of light. That means it travels some distance towards the left, returns to the center, then moves in an equal distance to the right. Let's say this is a photon, so it would move towards the left, some distance it will move to the left, and it will come back at its main position. This is the main position, and then it would slightly move an equal distance to the right before coming back again to the center and starting all over again. Imagine a ball tied on a string. So let's say this is a ball tied on a string, swinging sideways while you are walking forward. This vibration is called its frequency. The frequency decides its wavelength. I'm denoting wavelength through lambda, alright? That is the length it will travel forward for the duration of one complete vibration. Let me just show you the diagram, or whatever this is, the way it's shown. Right, so this is the displacement it is doing, which is right. So this is the propagation, all right, which is propagation is nothing but the direction of wave travel. So here we go. Wait. Alright, so now this is the crest. You should know the point. It looks like a mountain, and the top of the mountain is nothing but the crest, and the deepest point of the mountain, which is inverted, it is straw. And this is the amplitude. It means how much distance, displacement that particle did. It means that if less distance means less amplitude. If more distance it travels to the left or right, it means more the amplitude. It just means that. So this is called amplitude. Alright, amplitude. Alright, and this shows displacement. More the amplitude, more the displacement. And so this is also crest, this is also trough. Right, now the distance, this whole wavelength from one trough to another trough, or you can just say this one complete distance from one crest to another crest, it's called wavelength. This is called wavelength. I'm repeating what I just told you. The frequency decides its wavelength, right? More frequency means more this, more the times, more the number of times a photon oscillates. It means this one has higher frequency, but this one has lower frequency. So this frequency decides its wavelength, all right? That is the length it will travel forward for the duration of one complete vibration. The higher the frequency, the more energy the photon has, but its wavelength is shorter. You see, if this is higher frequency, and if to make it of lower frequency, then you will get it like this. More amplitude, but here less amplitude, right? I mean, this is the wavelength, right? And in more frequency, as you can see in this one, in the chart A, or whatever this graph is, in the A graph, as you can see, there is less frequency. No, sorry, it's more frequency. More vibration per second. But here, as you can see, there are less vibration. Means here is less frequency. And in the above A, it's more frequency. And now, as you can see, the distance from one crest to another crest, it has decreased as compared to this one. So more the frequency, the less the wavelength, and the less the frequency, more the wavelength. So this is how it all depends on each other. So we'll discuss the later topics like photoelectric effects, electromagnetism, visible light, and other waves or electromagnetic spectrum in our upcoming videos. So stay tuned and do follow the subscribe button. Bye bye.